Hello, at this part of the video we're going to see how to do a welding qualification in order to do a welding job by checking all the variables, essential variables, for a practical example. So this is our welding job. We have two weldings, W1 and W2. Both of them are circular weldings, and we're going to imagine that our company is going to do this job, and for that we need to qualify our welding procedures and our welders in order to do this job according to ASME section 9. So here we have a table where we can see characteristics of each of the welding joint. So here we have thicknesses, diameters, the materials. We have a 182 F11 class 2 P number 1, and on the W2 we have a 182 F11 class 2 plus a 387 grade 11 class 2. These are steels for working at high temperatures, grip resistant steels. So first of all, you need to see in our workshop how can we do the welding test. And let's imagine that we already have from other job pipe shape material, pipe shaped A250 T11 with this kind of measures: outside diameter 273 millimeters by 25.4 millimeters thickness. So we can do our welding test with this material because it's the same P number and more or less the same kind of parameters of the welding. So we're going to see now what are the welding processes that we're going to use in our welding job. So we're going to use GTO, which means gas tungsten arc welding. This is the American nomenclature, or it's also known as TIG, tungsten inert gas. This process is characterized by having the filler metal outside the welding torch, and the filler metal is not run by electricity, so is going to be part of the welding joint outside of the welding torch. The other process that we're going to use is flux cored arc welding, or FCO. In this process we have shielding gas like we had in the previous one, but on this process the filler metal is the electrode. It carries out the electricity to make the arc that will make the welding, to fuse the metals in order to do the welding joint. This process will be used in both welding joints, W1 and W2. The previous one will be used only in the W2 as a root pass in order to acquire better penetration, due to the fact that this is a tubular welding joint and we cannot reach the weld from the inside of the welding joint. So we're going to see the joint in the procedure test. So in the procedure test we don't have to have the same welding joint as in the work joints. The joint is not necessarily the same, because we can do our welding procedure if the tests confirm that we will be able to qualify for various number of welding joints. So the welding joint for our procedure test, in order to qualify for doing those joints that we have seen before, can be something like this. So the first two passes are from the procedure GTO, and then we have the filler and the other passes done by the flux cored arc welding. The first two passes by gas tungsten arc welding and the others by flux core arc welding. So once again, to remember that the joint used in the procedure test is not necessarily the same as the production weld joint. So this is the suggested format for procedure qualification records that is given by ASME section 9. What we're going to do is to fill all these camps, or not all, but almost all, in order to, starting by the PQR, procedure qualification records, and then we're going to, at the same time, we're going to do the WPS. This is the suggested format for welding procedure specifications, WPS, and we're going to put here all the range of qualifications that our PQR gives us if the tests would be okay. Remember that this is not a real test, just trying to show you how it could be done in order to achieve the results. So this is our ASME section 9. We're going to search for this table. So what we have here, this is the table KW 255, welding variables procedure specification for gas metal arc welding, GMO, and flux core arc welding, FCO. This is our process. So we have here the essential variables, supplementary essential variables, and non-essential variables. This means that essential, that these variables need to be addressed correctly in order to guarantee the mechanical characteristics of the welding joint. So we must address these variables, all of them. Supplementary essential variables are only needed when we have to address the impact resistance of the welding joint, and this is needed. This is the design of the structure that determines that, because depends on many issues: the minimum temperature of the design of the metal, and the thicknesses, and the kind of material, the type of material. So at this video we're going to address only the essential variables, and we're going to consider that our structure, our welding job is going to be used in a warm weather, in a warm place, not necessary to address the impact resistance for now. Then I'll do in the future another video when we will address these variables also. So we have a certain number of subdivisions. Essential variables for base metals, KW 403. You have here the essential variables, they are check marked with an X. We have filler metals, positions, preheat, post-weld heat treatment, gas for shielding, and electrical characteristics, and we also have technique. So we're going to address each of these variables. So first variable, thickness qualified. We're going to see paragraph, which is KW 403.8. So this is it. And what it says here: a change in base metal thickness beyond the range qualified in KW 451, except as otherwise permitted by this paragraph. Now, thanks to information already gathered before, we can start filling our forms. So in our PQR we can start filling the above inscriptions with the organization name, procedure qualification record, welding processes, so gas tungsten arc welding plus flux cord arc welding, manual types of welding, and the joint design. In our WPS we can start doing the same. This is our information that we can put right now. Joint design. Also in this table we can obtain the tests required to approve the welding procedure. In this case we have already seen that the thickness of the test coupon is 25.4 millimeters, so it stays around here. As we can see, for that thickness we must do 2 tension tests and 4 side bend tests. It says here note 4. In note 4 it says for details on multiple specimens when compound thickness are over 1 inch. And so this is our welding variables table for the process flux cord arc welding. So we're going to start analyzing this table by the variable KW403.8. So that's what we're going to look for. So 403.8. So we have it. A change in base metal thickness beyond the range qualified in KW451 except as otherwise permitted in this paragraph. So we have to click here and go to this table. This is a very important table because it's going to be the table where we're going to see the thickness of the welded joint that is qualified by this welding procedure. So as we have seen before, you can go into here. The thickness of our test coupon is 25.4 in millimeters. This is millimeters. So we now must go here and we've got to choose each line is the line indicated for this situation. So we have here 19 to 3/4 of an inch. We're not going to talk about inches, we're talking about millimeters. So 19 to less than 38. So this is our spot. But we have 2 lines with the same thickness. In the case of the thickness of the weld joint, we just need to check this out. So the minimum qualified is 5 millimeters. The maximum qualified is 2 times T. T is 24.5 millimeters. So we have this. In PQR, this is our base metal spot in this PQR. So we're going to put this. This is the characteristics of the base metal, material spec, type or grade, P number, group number, 2 P number, group number. So this means this material has this P number and group number. the thickness of test coupon and diameter of test coupon, as already been showed. In the WPS range of qualifications we have, so base metal thickness range, groove, as we were watching, 5 to 50.8 millimeters. This is exactly what we were talking in this table, 5 to 2 times 25.4. This is for groove weld tension, groove weld joints. When we talk about fillet weld, we must go here. Fillet welds qualified by groove weld tests. Thickness T of the test coupon as welded. All groove tests, range qualified. All fillet sizes on all base metal, thickness and all diameters. And we don't have to do any test because the tests are already made in the procedure of the groove weld. So this is why it says here unlimited. This is unlimited because this procedure will qualify for any thickness in case of fillet welds. So now we go again to this paragraph, and we always must see these paragraphs that are indicated. They can sometimes tell you important things and some restrictions or not for those things that the variable refers to. So we're going to have already seen that there's nothing to change in what we have done. So now we go back to our table and we go to the second essential variable. By the way, I didn't refer these non-essential variables. As the name says, these variables do not have big importance or no importance in the mechanical characteristics of the welding joint. This means that they can be changed. They can be changed. So we're not going to see them just because they can be changed. They must be indicated or should be indicated in the welding joint, in the welding PQR and WPS, but they can be changed. They are not essential. So going back to our essential variables, we go to the next one, KW 403.9. So now we go here. For single pass or multi-pass welding in which any pass is greater than 13 millimeters thick, an increase in base metal thickness beyond 1.1 times that of the qualification test coupon. In here we must guarantee that any pass has got more than 13 millimeters thick, and for that we can do this. This now goes away. So we have here that note 4, and it says here, see these paragraphs for details on multiple specimens when coupon thickness are over 1 inch. So since our thickness is exactly 1 inch, so we are not going to consider this note. So we are going to have here 2 tension tests and 4 side bends. For the tension test we click here, KW 150. Here we have it. It says here all the specimens must be. We've got to click these paragraphs to see that. For thickness up to and including 1 inch, A full thickness specimen shall be used for each required tension test. So we've got to cut a full thickness specimen. This is for plate, but we're talking about pipe. This is our situation. So this is KW 150. It says here how the test specimen must be, and we must go and search the tension test procedure and above all acceptance criteria. We have to obtain the amount of tensile strength, a minimum value at least, in order to pass the test, and for that we must go and search our material in this table. This is the table in the ASME section 9, where we have this column with the materials. We have all this specification number, and then we have type or grade, and we have all this information about the material. We also have in this column the minimum specified tensile strength. Obviously our welding joint must have at least this value or higher. So we're going to search our material. We have is SCA 250 G11. This is it. 415 megapascal. This is welded tube, our material. 415. So we must go here to put this in our PQR. Let's tension test. We have to do as we've seen before. We must have two specimens with 19 millimeters. This is taken from the ASME S section 9, full thickness, as we've seen before. This is our approximate area. This is something we don't know, we must obtain, and this is our minimum tensile strength for our test coupon. It must be bigger or equal to 415 megapascal. Type of failure and location outside each affected zone, preferably. And so, going on, we must go again to this table. We must do also two side bends, four side bends. This is the paragraph for guided bend tests, and we go here. This is our test transverse side bend. It means the weld is transverse to the longitudinal axis of the specimen. This means that it's perpendicular to the longitudinal axis of the specimen. These paragraphs refer to the explanation of how the specimens are. So we must go now search for acceptance criteria. So our acceptance criteria for bending tests will be in this paragraph, KW 163, and basically we cannot have open discontinuities in the weld or its affected zone exceeding 3 millimeters, measured in any direction on the convex surface of the specimen after bending. So we now go here to our PQR, and this is our guided bend tests table, and we must do 4 bend tests, side bend tests, exactly with that indication. Discontinuity smaller than 3 millimeters on the convex surface. So this is it. Now we go back to our ASME section 9 code, and we go into the table key W255 once again, and now we go to the essential variable number key W403.9, and we put this, and now here we have it. For single pass or multi-pass welding in which any pass is greater than half an inch, 13 millimeters thick, and an increase of base metal thickness beyond 1.1 times that of the qualification test coupon. Now in here we must assure that any pass of the weld is bigger than 13 millimeters. So we go here to, in the PQR we must do we have here maximum pass thickness. It's crucial to have this this comment: no pass is greater than 13 millimeters thick. And in here, in the WPS, the range of qualification is also that one. Yes, maximum pass thickness cannot be bigger than 13 millimeters. And this is how we fix that situation. Now we go again to our previous table, and now we go to key W403.10 essential variable. So we go here, search, there you have it. For the short circuiting transfer mode of the gas metal arc process, when the qualification test coupon thickness is less than 13 millimeters, increase in thickness beyond that of the qualification. So in this case, the only thing that we can say is that our test coupon thickness is bigger than 13 millimeters. So this variable doesn't apply to our case, to our situation. So now we go back to the previous table. Now we're going to do the next essential variable, that is 403.11. It refers to the P number qualified. So base metals specified in the LPS shall be qualified by a procedure qualification test that was made using base metals in accordance with KW 424. So basically we have to click in here and go to this paragraph of the ASME section 9. And so basically what we have here is base metals used for procedure qualification. Then we go to this table over here. This table will tell us what are the base metals qualified in the case of our welded joint in the procedure test. So in our procedure test we have one metal from P number 4 to any metal from P number 4. This is our situation. Okay, so this situation qualifies for any P number 4 metal to any metal assigned to P number 4, 3 or 1. So we now must go here in our WPS. We must do this. So this is the range of qualification for base metals. So pin number 4, group number 1, 2, pin number 4, 3 or 1, group number 1. So this is our range of qualification for the base metals. So now we go again to our essential variable table. Here we are. And now we are changing into filler metals. The first essential variable is F number. F number is the qualification or classification of the filler metal. So we go to KW 404.4. We're going to search that paragraph. And so here we are. A change from one F number in table KW 432 to any other F number or to any other filler metal not listed in table KW 432. So what this means is that we've got to go into this table KW 432. But first we have to go here into our PQR. In here we're going to fill the